Good morning, students. Today we are going to start a new lesson, that is real numbers. Nothing but number system. Okay, it's given in our first chapter, number system. In that there are two definitions are there. One is lemma. Lemma is a proven statement used for proving other statement. Okay, lemma is a proven statement. One example, suppose sun rises in the east. It's a proven statement. So the opposite direction of the east is west. So to prove that is as west, you need one proven statement. Then that is called a lemma. That lemma need not have any proofs. Okay, it doesn't have any proofs. So the next one is algorithm. An algorithm is a series of well-defined steps which gives a procedure for solving a type of problem. So here it is given a well-defined steps. Okay, what is that? Well-defined steps. What is meant by well-defined steps? Suppose for a rectangle is given. You have a symbol, a rectangle, A, B, C, D, of length 5 centimeters and breadth 3 centimeters. What is its area? What is its area? How to find out? There is an algorithm for this. That is, given length is equal to, what is that? Given length is equal to, first step, breadth is equal to 3 centimeters. At the same time, area is equal to, you need to write a formula, that is L into B. Third step, so substitution of L value and B value, then you need to multiply together, that is nothing but 15 square centimeters. So to find the area of rectangle, you need these many steps. So it is a well-defined steps which gives a procedure for solving. I solved this problem, okay, in a systematic procedure. This procedure will gives you the algorithm. Okay, so lemma and algorithm. And the next thing is Euclid's division lemma. Euclid is a mathematician. He proved a division lemma to us. That is, if A and B be two given positive integers, yes, positive integers, such that A is greater than B, such that A is greater than B. Suppose if I take A is equal to some 17, B is equal to 3. So definitely 17 is greater than 3. Then there exists a unique integers Q and R such that A is equal to, that means 17 is equal to B into something plus R, B into Q plus R. How to exist that is? Okay, now A is equal to, this is called Euclid's division lemma. When you divide this, I can write 3 5s are 15. So 2 is the remainder. So if it is A, I am dividing with B, then it is Q and it is remainder R. Then we have a rule, that division rule is equal to, dividend is equal to. Okay, what is that rule? Dividend is equal to divisor into quotient plus a remainder. Dividend is equal to divisor into quotient plus remainder. Then dividend is equal to 17 is equal to divisor 3 into 5 plus remainder 2. This is nothing but where 17 is equal to A, where A is equal to B into Q plus R. So this is called a division lemma. A is equal to B into Q plus R. And one more condition is given. It is very important condition, that is R. What is meant by R? Here, the division. This is less, okay, more than 0 or equal to 0 and less than the divisor. Okay, that means if you divide with 3, okay, if you divide with 3, we are getting the reminders. The possible reminders are there. Okay, I am telling all the possible reminders. I am starting with 15. So 3 5s are 15. 0 is the reminder. If I am doing with the 16, 3 5s are 15. 1 is the reminder. If it is 17, 2 is the reminder. And if it is 18, next number, 0 is the reminder. If next number continuously I am taking from 15, 16, 17, 18, 19, then it is 3 6 are 18. 1 is the reminder. Next 20, if I do it 16, that is 2 is the reminder. Again 21 if you take, then it is 0 is the reminder. So what are the reminders you are taking and you are getting? 0, 1, 2. When you are dividing with 3. So the possible reminders are, it is 0, 1, 2. When you are dividing with a number 3. When you are dividing a number 3, you are getting the possible reminders are 0, 1, 2. That means the reminder is always either 0 or less than, and you are getting any reminders like 1, 2, so on, but it is less than 3 only. You won't get the reminder 3. Less than 3 you will get, and more than 0 you will get. Suppose if I change my reminder as 5. My reminder as 5. That means you will get the possibility reminders are 0, 1, 2, 3, 4. Okay. If my quotient is 7, then the possible reminders are from 0, 1, 2, 3, so on, 6. So all the reminders will possible from 0 and less than the divisor. Less than 1, the divisor. It is giving the statement Euclid's division lemma. That is A and B, two positive integers such that A is greater than B. Then there exists two letters, that is Q and R, such that A is equal to BQ plus R. Dividend is equal to divisor into quotient plus remainder. For remainder, there is a conditions are given, that is 0 less than or equal to remainder less than B. This known as Euclid's division lemma. Now, Euclid's division algorithm. We already discussed about an algorithm. Algorithm is a series of steps how to solve a problem, a step-by-step procedure. Okay. Now, Euclid is given a division algorithm. Division algorithm. That is a technique to complete the highest common factor. That is nothing but HCF. Okay, HCF or GCD. Both we will call it as same. How to find out the highest common factor, HCF, of two given positive numbers. Okay. Now, what is Euclid's division algorithm? That is a technique to compute the highest common factor, HCF, of a given two numbers. So, what are the steps required in this division algorithm? Okay. The first step is take two distinct positive integers. Okay. You need to take two distinct positive integers, A and B, such that A is greater than B. So, you need to take two numbers, okay, two distinct, means different positive integers, such that A is greater than B. Now, I am taking, okay, I am doing one example as following these steps. Okay, as I am following these steps, I am doing one example. That is, if A is equal to 225 and B is equal to 135, such that A is greater than B. Two distinct positive numbers I am taking. My second step, divide A by B and represent quotient as Q and remainder as R. So I should divide. So 135 that is 225 divided by 135. If I take 2 times 135, it is, come on, it is more than 225. Okay, so I am taking 1 time. So 135, that is nothing but 5 minus 5, 0. Okay, 12 minus 3, 9. 90 I got it. So what is my Q here? Quotient is Q, remainder is R. Okay, divide A by B and represent quotient is Q and the remainder is R. Quotient is Q, remainder is R. Now my third step, if R is 0, then declare B is the HCF of A and B. If it is 0, yes, 135 is the HCF of 225 and 135. Is it 0? No. If no, what you should do? If R is not equal to 0, then take B as dividend. What is that? B as dividend. You have to take B as dividend and R as divisor. So now your dividend and divisors are different. So B as dividend. So in the division procedure, this is divisor. Okay, what is divisor? R. I am taking R is divisor. B is dividend. What is dividend here? 135. Okay, I am taken. Now after division, I should divide. If I take again 2 times 180, it is becoming more. So again 90, 5, 4. Okay, now after division of B by R, represent quotient so obtained is Q and remainder so obtained is R. Okay, this is Q1 and it is R1. What is my Q1? 1. What is my R1? 45. Now check. Okay, now check that R1 is equal to 0. Is R1 is 0? No. Suppose if R1 is 0, if any sum if it is got 0, then R will be the HCF of A and B. Okay, R will be the HCF of A and B. But it is not 0. Then what happened? What we should do? This process will continue till the remainder comes out 0. You should do this process continuously. Now R1 as the divisor and R is dividend. This process you should continue. 2 into 45, that is 90, 0. That means now my Q2 is 2 and R2 is 0. Yes, at R2 it is 0. Now the remainder is 0. So in which step of division the remainder comes 0? The divisor of the step is the HCF. In which step? In this step, remainder is 0. Then, okay, then the very important word is the divisor is the HCF of A and B. Okay, the divisor. Which step? 1, 2, third step. In third step, divisor is how much? 45. Therefore, HCF of, okay, 225 and 135 is 45. Okay, so this is the process is known as Euclid's division algorithm. Algorithm means it's a step by step procedure it will give. So Euclid is divided. Okay, Euclid is stated one algorithm for finding HCF of any two numbers but the condition is that two numbers should be distinct positive integers. So this Euclid's division algorithm is limited for A and B, where A and B are distinct positive integers. Okay.